Okay, now let's look at some examples of how we use the limit definition of the derivative to find the derivative of the given function. So let's start out with a nice basic one. We've got a constant function, f of x equals 10. So remember, our limit definition of the derivative tells us that f prime of x is equal to the limit as h is approaching 0 of f of x plus h minus f of x all over h. And so we know then, substituting in, so x plus h, we substitute that in everywhere we have an x. But in our constant function, f of x equals 10, we don't have an x. So what is f of x plus h? Well, that means we're going to evaluate 10 whenever x is equal to x plus h. So this becomes the limit as h is approaching 0 of 10, because f of x plus h is 10, minus f of x, well, f of x is 10, all over h. So this is the limit as h is approaching 0 of 10 minus 10 is 0 over h. Now keep in mind, we can't direct substitute yet, right? Because if we direct substitute into this, what's going to happen? We're going to have 0 over 0, which we can't do. But we can simplify first. So we're still within our limit notation, so notice that limit notation is being carried along because we haven't evaluated the limit yet. And so limit as h is approaching 0 of 0 over h, well, let's simplify. So that becomes the limit as h is approaching 0. What's 0 divided by anything other than 0? 0 divided by anything is 0. So this is the limit as h is approaching 0 of 0, which then gives us, now we can evaluate, so the limit as h is approaching 0 of a constant, remember then, is that constant. So the limit as h is approaching 0 of 0 is 0. So in this case, f prime of x is equal to 0. So let's think about it. Does that make sense? Should we have gotten 0 in this case? So remember, what is f prime of x? What is the derivative of a function? It's the slope of that function at a point, right? So if we think about what type of line is the function f of x equals 10. It's a horizontal line along y equals 10, right? And what's the slope of a horizontal line? Anywhere, it doesn't matter where you're at on that line. It's 0. So this answer makes sense. So the derivative is 0 in this case. And that's going to be true of any constant function. Although, yes, you still have to show me all the work. All right, now let's look at a linear one. So f of x equals negative 5x plus 2. Now, logically, we know, again, okay, if this is a linear function, then the slope of the linear function is going to, in this case, be negative 5. So we know that logically, but now let's prove it. So let's actually find the derivative. So f prime of x equals the limit as h is approaching 0. You can also do limit as delta x is approaching 0. I tend to use h just because I don't like having to write out all those delta x's and keep track of them. And especially if you have x's and delta x's mixed together, it can get kind of confusing. But I'm going to show you both ways. I don't care which way you do it as long as you're not losing stuff and you're evaluating the limit properly. I'm going to tend to use h, but your book uses delta x. So I'm going to show you both ways. So f prime of x is limit as delta x is approaching 0, f of x plus delta x minus f of x all over delta x. Notice this is the exact same as our definition above. The only difference is that we now have delta x instead of h. Otherwise, it's the exact same. So it doesn't matter which way you do it. So evaluating f of x plus delta x, remember everywhere you have an x, you're going to substitute x plus delta x. So in this case, this is going to be the limit as h is approaching 0, negative 5x plus delta x plus 2. So there's our f of x plus h. Minus, now be careful, you're subtracting the entire f of x. So I encourage you, write it in parentheses the first step. Don't just try to distribute the negative through as you're writing it out. That's usually where I see a lot of the biggest mistakes on this, is people will try to go ahead and distribute that negative through, and not carry it all the way through. So take the time. It takes you maybe a few seconds longer to write out this extra step. Write out the f of x inside parentheses. So you're subtracting that entire f of x. So we're subtracting negative 5x plus 2 all over, and I'm sorry, I should have limit is delta x, not h down here. So limit is delta x is approaching 0. Make sure you're not mixing that notation up and having h's and delta x's in the same one. That wouldn't be good, because then, well, delta x wouldn't. If I had limit as h is approaching 0, you couldn't do it. And so then all over delta x. So now let's go ahead, limits delta x is approaching 0. Let's clean this up a little bit. So negative 5 times x plus delta x. So that's going to be negative 5x minus 5 delta x plus 2. Now distribute this negative through. So minus a negative 5x becomes plus 5x. And minus a positive 2 becomes minus 2. All over delta x. Notice I'm still carrying that limit as delta x is approaching 0 along, right? Because I haven't substituted in yet. Now 5x, I've got minus 5x plus 5x. So those are going to cancel. I've got plus 2 minus 2, those are going to cancel. And so I'm left with, then, the limit is delta x is approaching 0. Negative 5 delta x over delta x. Now guess what happens? What is delta x over delta x? It's 1, right? So we're left with, then, the limit is delta x approaches 0. Notice I can't just jump and say that this is negative 5, right? Because I still haven't simplified that limit. So we're canceling the delta x's. So then this becomes limit as delta x is approaching 0 of negative 5. And now we know the limit of the constant is the constant no matter what it's approaching, right? So then this becomes negative 5. So f prime of x, or the derivative of f evaluated at x, is negative 5. And again, remember, that was our slope up here in the original function, right? So it agrees, as it should. All right, now let's think about a quadratic equation. So in this case, so f of x equals 3x squared minus 2x. So if we think about this, now that slope is not going to be the same everywhere on that curve, right? Everywhere on that parabola. You've got some areas where you have negative slope, you have one spot at the vertex where you have 0 slope, and then you have the other side where it's positive slope. So the slope's not going to be the same. So we need to figure out a way to find the slope no matter where we're at. So a nice function to give us a formula to find the slope for anywhere on this parabola. So same idea. So f prime of x equals the limit as h is approaching 0 of 3x plus h, quantity squared now. So again, remember, it's f of x plus h. So remember, f prime of x equals limit as h is approaching 0 of f of x plus h minus f of x all over h. So then everywhere we have, if we're finding f of x plus h, everywhere we have an x becomes x plus h. So 3x plus h squared minus 2 times x plus h. So that's our f of x plus h. Minus now the entire f of x. So minus 3x squared minus 2x, all in parentheses. All divided by h. So how can we clean this up a little bit? Well, the easiest way is to go ahead and full out x plus h squared and then distribute everything through and see where that gets us. So limit as h is approaching 0. 3x plus h quantity squared, so that's x squared plus 2xh plus h squared minus 2x plus h minus, I'm going to go ahead and distribute this negative through, so minus 3x squared plus 2x all over h. Coming down to the next line then. So this is then limit as h is approaching 0 of 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h once we distribute everything through now. And so now some stuff's going to clean up. So we have 3x squared minus 3x squared. We have a minus 2x and a plus 2x. And so then we're left with limit as h is approaching 0, 6xh plus 3h squared minus 2h all over h. Well, what can we do? Well, there's a common h in everything in the numerator, so let's factor that common h out. So this becomes then limit as h is approaching 0, h times 6x plus 3h minus 2 all over h. And now, so it's important to make sure you're showing every step. So now the h over h cancels. And so we have limit as h is approaching 0 of 6x plus 3h minus 2. We've taken care of division by 0. Now we can directly substitute into this for h. So subbing in 0 for h, we now notice the limit notation is going away because we have evaluated the limit. So 6x plus 3 times 0 minus 2, which then just gives us 6x minus 2, which is f prime of x. So what this is, so the derivative is a formula for slope of the tangent line, or formula for the slope of the curve at any point on that curve where it is differentiable at. So in this case, what's that telling us? It's telling us the slope of the quadratic function 3x squared minus 2x is the linear function 6x minus 2. Does that make sense? Yes, because if you think of what a linear function looks like, right, 6x minus 2, you're going to have part of it that's below 0, one value where it's at 0, and part of it where it's above 0. Every single quadratic function will have a linear derivative. Now a fun one. So what if we have a rational function? So f of x equals 5 over x plus 2. Well, we do the exact same thing. So f prime of x equals the limit as h is approaching 0, 5 over x plus h plus 2 minus 5 over x plus 2 all over h. So where do we go from here? Well, we simplify this complex fraction like you did back in the algebra view and like you did last week with some of the limits. So in this case, what we want to do is we want to multiply our numerator, the complex fraction numerator, and the denominator of the fraction as a whole by our common denominator of x plus h plus 2 and x plus 2, which in this case is just the product of the two. So we end up with 5 over, limit as h is approaching 0, of 5 over x plus h plus 2 minus 5 over x plus 2 all times x plus h plus 2, x plus 2, all over, in the denominator, same thing, because otherwise we would have changed our fraction. So multiply numerator and denominator by the same thing. So now when we clean that up, that's going to become 5, x plus h plus 2's are going to cancel. And so we're left with just 5 times x plus 2 minus 5 times the x plus 2's cancel here, and we're left with x plus h plus 2 all over h, x plus h plus 2, x plus 2. For the time being, I'm not going to multiply the denominator out. I am going to clean up the numerator, though. You've seen me use this trick before, so this becomes limit as h is approaching 0, 5x plus 10 minus 5x minus 5h minus 10 all over h times x plus h plus 2 times x plus 2. Cleaning it up becomes limit as h is approaching 0. And so the 5x's cancel. Plus 10 minus 10 cancels. And so we're left with the limit as h is approaching 0 of negative 5h over h, x plus h plus 2 times x plus 2. Now my h's are going to cancel. And so I'm left with then limit as h is approaching 0, negative 5 over x plus h plus 2 times x plus 2. Now it doesn't look like there's anything else I can do. I've still got an h in the denominator. So what can I do? Well, if you look at it though, what's going to happen? We're not going to have division by 0 if we substitute in now, are we? So let's go ahead and substitute in for h. So this becomes then negative 5 over x plus 0 plus 2. So just x plus 2 times x plus 2, right? Which then is just negative 5 over x plus 2 squared. And that is f prime of x. Let's do one last one. So f of x is equal to square root of x minus 5. So same idea. So f prime of x is equal to limit as delta x is approaching 0. Do another one with delta x notation. Square root of, so x plus delta x. So that means this is going to be square root of x plus delta x minus 5 minus square root of x minus 5 all over delta x. What do we do if we have radicals? We multiply numerator and denominator by the conjugate. So this is going to become limit as delta x is approaching 0. So our original square root x plus delta x minus 5 minus square root of x minus 5 all over h, but times the conjugate. So what's the conjugate of square root of x plus delta x minus 5 minus square root of x minus 5? Remember to find the conjugate if you have two radicals. You just reverse the sign in between them. So this is going to be, the conjugate's going to be x plus delta x minus 5 plus square root of x minus 5. And well, if I multiply the numerator by it, I also have to multiply the denominator by it. So square root of x plus delta x minus 5 plus square root of x minus 5. So now let's multiply this out, clean it up a little bit. Limit as delta x is approaching 0. Sorry, this should be a delta x up here as well. So square root of x plus delta x minus 5 times minus square root of x minus 5 times square root of x plus delta x minus 5 plus square root of x minus 5 just gives us x plus delta x minus 5 minus x minus 5 all over this ugly denominator that I do not recommend multiplying out right now. Don't distribute that delta x through. Square root x plus delta x minus 5 plus square root of x minus 5. So clean up the numerator a little bit. So this is limit as delta x is approaching 0. We have an x minus an x. So let me go ahead and just write out the distribution first. So x plus delta x minus 5 minus x plus 5 all over this ugly denominator delta x times square root of x plus delta x minus 5 plus square root of x minus 5. Don't forget your parentheses around this radical grouping, right? So this sum of two radicals. Since you're multiplying delta x by the entire thing, you've got to have those parentheses, right? And so that becomes limit as delta x is approaching 0. Now our x minus x, negative 5 plus 5 cancel. And so I'm just left with delta x in the numerator. And then all this ugly stuff, delta x, square root of x plus delta x minus 5 plus square root of x minus 5 in the denominator. Delta x's cancel. So what is delta x over delta x? So what am I going to have in the numerator? So it's going to be limit as delta x approaches 0. 1. So delta x over delta x, remember, still 1. So you still have a 1 in the numerator. So 1 over square root of x plus delta x minus 5 plus square root x minus 5. And at this point, sort of like above in the complex fraction, now I can substitute in, right? Because I don't have division by 0 anymore. So when I substitute in for delta x equaling 0, it becomes now, so 1 over square root of x plus 0 minus 5 plus square root of x minus 5. And what is square root of x minus 5 plus square root of x minus 5? Notice now my limit notation's gone because I've substituted in for delta x. So this just becomes 1 over 2 square roots of x minus 5.